Hi, and welcome back to the second video of our web programming lecture series. To recap, in the first video we had a quick look at the internet, how it works, and its notion of being a network of networks, the World Wide Web, and we took an in-depth look at HTTP as a request-response model, what its messages look like, and how to view real HTTP messages via Chrome Developer Tool. In this video, we're going to cover software architecture, what it means and why we use it in software engineering, and then we'll take a more specific look at client-server architecture and end-tiered architecture. In this course, our job as software engineers is to build a system or piece of software to meet a user's or customer's needs or to solve a problem. We may have to build a system to manage medical appointments from multiple medical centers, or we may have to build a platform to administer pay for a company's employees. You may be thinking, surely someone has done this before. There already exist payroll systems, social media systems, and booking software. And you would be right. Many of the problems we see in software engineering are a new look on an old problem. Software architecture is concerned with finding patterns in existing software solutions and utilizing them in future work to save time. When delivering a project, we want to minimize our wasted time on unnecessary tasks. If there is a known way of achieving a task, why wouldn't we use it? If we can use a package that can reliably and quickly sort a list for us, why would we waste time writing our own sorting algorithm? A formal definition of software architecture is the big picture organization of a system or a piece of software into a logical series of subparts. For this course, we are aiming to build a web application, a web server, to provide some sort of platform for users to achieve a defined purpose. We can simplify this goal. We want to provide a web server that a user can send and receive data from. Now we can formally introduce client-server software architecture. We have the goal of building some software which can hold, send and receive information and provide a service. We want to have multiple users who can access and retrieve this information from a single source, as well as interact with the provided service in a unique way. An example of this is Facebook. You and I can both access Facebook at the same time, but I'm accessing my account and you're accessing your account. We are both accessing the same service, but interacting in a tailored way. This means if we have to write a web service, such as booking software or a payroll platform, we can utilize client-server architecture and write two separate programs, a client and a server, who interact in a specific way. This can save time thinking about how to approach the problem of sending and receiving data and possible methods of implementing a solution. For this course, we are only going to have to write the server software because our client software already exists. It is simply a web browser, such as Google Chrome or Firefox. So let's take a closer look at what client-server architecture really is. We have a client that is software the user uses to access and request information from a source or to access a specific service. That client is accessing information from a server, that is software that responds to requests providing either the specified information or service. These are two unique independent pieces of software that communicate over a given protocol. In our case, our server is going to be our Flask application, our client is going to be a web browser, and our protocol is going to be HTTP. There are three key things to remember about client-server architecture. There is one server and many clients, meaning one piece of software that holds resources and many pieces of software that can access and interact with these resources. Secondly, it is a request-response model, meaning the server will only ever act when it is responding to a request from a client. And finally, client software and server software are independent programs running. They communicate over a defined protocol such as HTTP. All software architectures have pros and cons. These help us to make a decision about whether or not a specific software architecture is right for a given problem. In terms of client-server architecture, its benefits lie in the fact that it is relatively simple and a two-part architecture. Since all the clients are going to use the same software, we only have to write two programs, a client program and a server program, as well as a protocol for the two to communicate. Also, as all the resources are located in one place, the client knows exactly where to access a given resource at any point in time. The main con of client-server architecture is that as a system acquires more users, it is going to put more of a strain on the server as it is responding to more requests. This means as the system scales, it is going to need more resources to maintain the server. In summary, remember that a client requests information from the server, and the server will send back a message to the client, either containing the requested data or providing a reason with why it could not send the data. Next up, we're going to have a look at n-tiered software architecture. As we saw with client-server architecture, the main benefit lies in splitting up software into components that interact in a logical way. This notion of separating software into multiple components can be extended to 3-tier and n-tiered architecture, where we split up software into logical subparts that can be run on the same or different computers. Typically, n-tier architecture separates the deployment of components into multiple layers that are run on separate computers. It aims to separate the software based on the concerns of the business. While we have looked at the generalized version of this architecture, the 3-tiered architecture is the most commonly used, featuring a presentation tier, a business tier, and a data tier. Another common breakdown of 3-tiered architecture is into their presentation, logic, and data tier. We can see here that the user interacts with the presentation tier in the form of the UI. The user may press a button or type something in. This information then gets sent to the logic tier. Then, depending on what the user has done, the logic tier will then send some query to the database to either access or modify information. Depending on what the database sends back, the logic tier will then decide on what it sends to the user. For example, a user may click on a login button, entering a username and a password. The logic tier then collects this information and queries the database for the actual password of that specific user. If the passwords match, the logic tier will then send that information back to the presentation tier, where the user will then be redirected to the home screen. Like client-server, n-tiered architecture has its own pros and cons. Some of its pros include the separation of modules allows for distribution of roles and responsibilities amongst several independent machines. This means easier maintenance, as fixing an issue usually means only fixing one module. It also allows for easier reuse, as each module is built for a distinct purpose, meaning if you build another application that requires the same module, then you can use the same module again with minimal to no modification. Deployment of each module is on an independent server, meaning the service does not have a single point of failure and is more secure, scalable, and has better performance. The main con of n-tiered architecture is that it is complex and expensive, as you have to deploy multiple programs running on multiple machines, which is much more complex than running a single program on a single machine. For any of you with experience in building applications, you may be thinking that 3-tiered architecture sounds a lot like MVC. MVC is an application architecture where we divide an app up into 3 parts: the model, the view, and the controller. The view is what the app looks like and how the user interacts with the application. The controller receives information from the view and decides what information to change or access from the model and what view to return back to the user. The model is the data that needs to be stored. This may be user accounts or photos you've uploaded. It depends on the purpose of the application. For example, on Facebook, you may be on your newsfeed, which is a view shown to you through the Facebook application. You may then click on your profile photo. This information is then sent to the controller, which sees that you want to access your profile. It then queries a Facebook database, asking for your profile details, such as your name, friends, and photos. This information is then sent back to the controller, which inserts it into a profile view and returns it to the user. This all happens within the one Facebook application. 3-tiered architecture relates to the hardware level, where 3 layers are deployed on 3 different machines, whereas MVC refers to the breaking down of an application into 3 different software components. These 3 components may run on a single server or a single machine, or may be broken down and run on separate independent machines. 3-tier architecture aims to address hardware issues such as reliability, scalability, and security, while MVC aims to address software design issues such as software coupling and cohesion. In this video, we had a look at what a software architecture is and why we need them, what client-server architecture is, and tiered architecture, and we had a brief look at what MVC is.